All right, so example 5, it says what is the quotient of x squared plus 2x plus 1 over 1 minus x squared and x squared plus 3x minus 4 over x squared plus 5x plus 4. So quotient means to divide, so you see the quotient, it's division. And when we divide, we usually divide in the order that they give us the stuff unless told otherwise. So when it says quotient of this and this, the division symbol is going to go here with that first, that second. Now if I write down the problem as written, it's x squared plus 2x plus 1 over 1 minus x squared divided by x squared plus 3x minus 4 over x squared plus 5x plus 4. All right, so what I want to do now is I want to change this to a multiplication problem. And the rule about dividing fractions we learned back in 5th grade. We didn't have these kinds of fractions in 5th grade, but it still had division of fractions. It's the same idea. Is we don't do division of fractions, we instead do multiplication of reciprocals. So what we're dividing by, in this case the second fraction, we're going to reciprocate, change it to a multiplication problem. So it becomes x squared plus 2x plus 1 over 1 minus x squared. I'm going to change the division to a multiplication sign, and I'm going to invert or reciprocate the second fraction. So x squared plus 5x plus 4 is going to go on top. X squared plus 3x minus 4 is going to go on the bottom. What I want you to see, though, in this problem, with the whole idea of domain, because it's going to come up in these problems, right here, x squared plus 5x plus 4 is in the bottom. Right here, x squared plus 3x minus 4 is in the bottom. So that second fraction, neither the top nor the bottom can equal 0. So we're going for domain. Any point in the problem where we have stuff in the denominator, we have to establish domain based on that idea. So at one point, this was on the bottom. Now at another point, this is on the bottom. So both pieces of this fraction end up on the bottom at some point along the way in this problem. So when I go for domain in this one, I have to consider what makes this 0, what makes this 0, and what makes that 0. Those three things are all going to play into the domain. Other than that, everything else is the same as it was before. You've got a multiplication of rational expressions problem. I want to factor my quadratics. If I start with x squared plus 2x plus 1, that's just a simple quadratic trinomial. We're looking for factors of 1 that add to make 2. Those numbers be 1 and 1. So x squared plus 2x plus 1 is x plus 1 times x plus 1. The bottom is a binomial structure, so we have three possibilities for binomials other than the greatest common factor. Those are difference of 2 squares, difference of 2 cubes, sum of 2 cubes. As you can see, 1 squared, x squared, opposite signs, so this is difference of squares. So that factors to 1 minus x times 1 plus x. And the 1's are in front because 1's in front. The x is in the back because x squared's in back. So make sure that the order is correct. If we look at x squared plus 5x plus 4, that's a quadratic trinomial. We need factors of 4, numbers that multiply to make 4 that add to make 5. Those numbers would be positive 1 and positive 4. So x plus 1 times x plus 4 does the trick on that one. 1 times 4 makes 4, 1 plus 4 makes 5. And then finally, x squared plus 3x minus 4. You can see that we have x plus 4 and x minus 1 would make that work. At this point, once I've factored everything completely, now I'm going to try and reduce the fractions. Okay, and I do that by finding the same thing that happens on top and bottom. So notice x plus 1 and 1 plus x, they're in exactly the same order, but addition's commutative, right? So x plus 1 and 1 plus x should be equivalent, so those cancel. X plus 4 and x plus 4 are equivalent, so they cancel. Nothing else cancels, right? So all that I can do at this point is to multiply back together what I've got. On top I've got x plus 1 times x plus 1. On the bottom I have 1 minus x times x minus 1. In each case that's a binomial times a binomial structure, so that's just going to be a FOIL to multiply them out. So on top I'm going to have x squared, first times first. Outsides 1 times x is going to be 1x. Insides 1 times x is going to be 1x. And last times last is going to be plus 1. On the bottom, first times first, 1 times x is x. Outsides 1 times negative 1 is negative 1. Insides negative x times positive x is negative x squared. And last times last, negative x times negative 1 is positive 1x. So the top simplified out is going to be x squared plus 2x plus 1. The bottom simplified out, I got negative x squared plus 2x minus 1. It is tempting, since those look so much the same, to try and cancel more stuff out. Again, cancellation happens in the factored part here. If we don't have matching factors, things don't cancel, even if they look pretty at the end, like, hey, look, those both say x squared. Oops, I should say minus x squared. These both say x squared, those both say 2x, those both say 1. Let's try and cancel some stuff. The signs don't match up, so cancellation doesn't happen. As for domain, again, when I'm looking at domain, everything that was on the bottom at some point during the problem needs to be considered here. This has always been on the bottom. This was on the bottom when we flipped, and this was on the bottom before we flipped. So all three of those places were at some point in the problem on the bottom. So anything making any of those factors equal to 0 represents a domain point. So when I say x is not allowed to equal certain numbers, anything making 0 on any one of these factors represents a point at which that's the domain issue. So this makes positive 1, this makes negative 1, negative 4, positive 1, negative 4, negative 1. So there's a couple repeats. Negative 1 happens twice, negative 4 happens twice, positive 1 happens twice, but 1, negative 4 would be my domain. X is not allowed to equal those numbers.